Assalamu alaikum and good day. In this video, I am going to explain example 3 in Locus chapter. So we have loop transfer function of a control system that is given by kgh, which equals to ks plus 2, s squared plus 2s plus 2. From the characteristic equation, we take the 1 plus gh here. We know that we have n equals to 2, which is the number of poles, and we have m equals to 1, which is the number of 0. And we know that the quadratic equation, we can find the poles at negative 1 plus j, and the other one is negative 1 minus j. So the root locus begins at poles of gh, and root locus ends at zeros of gh. In this case, we have only 1 0 at negative 2, and the other ends of this root locus is ends at infinity. So we put all the information together onto the S-plane, and what we have is we have at this position, so this is negative 1, this is j, this is minus j, and we have another one 0 at negative 2. So what we do next is we find the root locus. So we take the root locus on the real axis. So we only have 0 at negative 2. So we have this root locus. We draw to the left. Okay. And since we know that the root locus will end at zeros, so we have one end at negative 2, and the other one is end at infinity. So we have another one here. So the root locus begin at pole k equals to 0, k equals to 0, and ends at 0 where k equals to infinity, and the other one is k approaching infinity at this point of location. And we know that the root locus should be start from 0 and ends at the root locus start from pole and end at 0. So we know that this root locus will start from this point and it travels through here, and the other one is a mirror. There is one properties in the root locus construction. If we have a complex conjugate, then we have the root locus is asymmetrical to the real axis. So we have this arrow travel from the pole towards the 0, and the other one from the pole toward the infinity. So there is a point that called here is break-in point. So we need to find this point later on. So from the information, we know that our n equals to 2, m equals to 1. So our asymptotes is equals to n minus m equals to 1. And we can find the asymptotes angle equals to 2k plus 1 pi, which equals to, we have only one asymptote, so k equals to 0. So we have pi or 180 degree. So it means that the angle of these asymptotes is along the real axis. Okay, since we only have one asymptote, so no need to find the intersection of asymptotes. Okay, so what we need to find next is we need to find the break-in point. And we can find the break-in point using dk over ds equals to 0, and we have our 1 plus kgh equals to 0. So we rearrange the equation so that we have k equals to negative s squared plus 2s plus 2 over s plus 2. And then we can use d over ds equals to, d over ds u over d, or u over v, v u prime minus u v prime over v squared. So we have our v is s plus 2, and then u prime is 2s plus 2 minus u, our u is s squared plus 2s plus 2, and we have v prime equals to 1, and then divided by v squared. And then we can solve for this equation, simplify, and then finally we come to this quadratic term. So we have negative s squared plus 4s plus 2 equals to 0, and we find the factor of this quadratic polynomial is equals to s equals to negative 0.586 and s equals to negative 3.414. So these poles valid break-in point. We need to look at this our drawing. So we have only one break-in point, which should be passed to negative 2. So in this case, we consider this negative 3.414. So we have this at this occasion. So I just put it here. So this point is negative 3.414. Is a valid break-in point. However, negative 0.58 here located at this, let's say this point. So this point is not a valid break-in point. Alright. So we have successfully complete the example 3. So we have this kind of drawing, and you can compare this drawing to the drawing that have in the lecture slides here. And it's pretty much a simple root locus because we only have 2 poles and 1 0. So if you have any questions regarding this example or any other questions, please let me know. Just contact me via WhatsApp, or you can ask me during the lecture session. Until then, thank you very much for your attention. See you in the next video.